Hi, my name is Arieh, and I wanted to talk to you about the product that my team and I have been working on with our mentor, Alex, a leading security architect for Goldman Sachs. The 5 members of our team are all computer science students at Yeshiva University, going into our second year in the program. We signed up for this course to get hands-on experience in software development, to spend our summer building something outside of the typical classroom assignment. We spent the first couple of weeks learning about new technologies, with the rest of our time spent putting our new skills to use, while building a fully functional product that we're excited to share with you. Before the team gets into the technical side, I wanted to tell you a little bit about the platform. We set out to build our very own customer relationship management system, or a CRM. A CRM is typically used by businesses to help connect with their customers and understand their needs, but we took a different approach. Using the ideas that are central to a CRM, we built the system to connect volunteers with organizers, giving users an easy way to find volunteer opportunities that they would actually be interested in. And on the other side, organizers can manage their volunteers effectively and efficiently. With that in mind, we built Platinum Volunteers, a system focused on connecting organizers with volunteers. It can be hard to find volunteers for your charity or organization, and we understand that. Our users post events for upcoming volunteer opportunities, which show up on the feed for the rest of our users. They can browse and filter through events, sign up for what they're interested, or skip that which they're not. And on event day, our notification system reminds our volunteers about the event, and our check-in system helps organizers manage their volunteer team. Our suggestion system helps find events that our users would be interested in based on their volunteer history. There's a number of things we focused on when we built our platform. We wanted to build an interface that anyone can use, making it easy to find and post events. Having a secure way to log into our system enables our system to manage our users and the events that they're interested in. And like any CRM, data storage is crucial. We wanted to be able to store events, both past and present, and the data associated with our users. We worked on the notification system and third-party integration to make the user experience as easy as possible. With that being said, let's take a look at our website. You can visit our site at platinumvolunteers.com, where you'll be greeted by the homepage. There is an easy way to get started. You can view events, you can post an event, you can view the featured events. When you click the View Events tab on the top, you can see the upcoming events. Each card, a different event, with the title of the event, the host, a description, the date and time. But when you click an event, you get a more descriptive view of the event with the volunteers, the weather, the location. Let me log in for this demo so we can actually see how you volunteer for an event. Now, once you're logged in and you click an event, you can filter through the events based on distance, based on tags. But if we look at past events, upcoming events, but if we take a look at all these different events, you can actually volunteer for the event. So you'll see, I'm going to click this volunteer, this event button, and it volunteers us for the event. Now when I go to my profile and I view my upcoming events, I can see all the events that I have signed up for. I can see my suggested events, and I can see the history of all the events I've done in the past. That's just some of the features about our website, and I'm now going to pass it on to the rest of our team to explain the more technical side of our project.
Hi, I'm Azriel, and I'm going to go over the architecture of our application. So the front end of our application that Arieh just showed you is all written in JavaScript using the React library. Our website is hosted on AWS Amplify, which integrates with Cognito and S3 to allow for user authentication and for the storage of user avatars. Our data is stored on multiple Dynamo DB tables that are accessed from the front end through the API Gateway, which calls a Lambda function that returns the data or does whatever we need to do in the tables. We also have an ECS cluster running different microservices to take care of other tasks. So as I said, our web application is written in JavaScript using React. So we use Semantic UI for a lot of the user interface elements you see here, such as all these cards and the buttons and all these stuff are taken from Semantic UI. We also use a React router to be able to display different pages, such as the home page or the event page or the post-event page. Those are all accessed using a React router. And the React states are used to display dynamic content, such as when you switch to show past events or upcoming events. So new users are asked to create an account with the email address and password, along with additional information. When they type in that information in the create account page, that information is all stored in a React state, which we take all that information stored in the React state and we pass it into the Amplify's auth.signup function, which will send an email to the user with a confirmation code that they must enter to create their account. And then that Amplify adds that new user to the Cognito user pool. And we also create an entry in the Dynamo DB table to store user data. And now that once that user's created, the user can go to the logon page, and that information is also stored in the state and passed into Amplify's login function in order for the user to log in. Users have the ability to create an event. When they go to the create event page, they must enter the event name, description, information, and if they want, they can also put in a money raising goal. They put in all the information in addition to tags, which can be used by other users to filter events. Once all that information's in and they click submit, we take all that information and pass it into our API pass all the information into our API, which will create a new event in the events table with all that information. Which then, once that information is all in the table, that table is called to display all our events. So now when users want to search events, they can open the events page, which displays all the events from the event table, which are accessed through our API Gateway and Lambda. They can see all the events. They can search for events by keywords. They can filter and sort. You can sort all events alphabetically. You can filter events only with the tag, let's say sales marketing. And if you see, you can go to that event, you'll see sales marketing is going to be one of the tags. And that's how users can search our events. Users also have the ability to register for these events. So when a user goes to an event and they click volunteer for this event, their user ID is added to that events table of volunteers, and this events ID is added to the user's table of upcoming events. You also have the ability to leave an event that you're already registered for, which does the reverse. It removes from both tables.
The first chunk of back-end infrastructure is the mechanism that we used to store and retrieve data from the database. To connect the front and back-end code to the database, an API gateway was set up to listen for requests. The body of these requests were then passed to a Lambda function, which completed a specified operation on the database and, if necessary, returned information to the API caller. The API gateway has two routes, /users and events. This convention kept our API calls organized and made the code more readable. The API gateway listened for post requests and passed the body of the requests onto the Lambda function. And the main challenge of setting up our API gateway was enabling CORS. By default, cross-origin resource sharing, aka CORS, was not enabled, meaning that our API would refuse to return data to the caller. This problem was solved by adding the necessary CORS headers to the method request and responses in the API gateway console. The Lambda function is the only piece of code that has the ability to directly read and write to the database. The Lambda function is triggered when the API gateway is invoked, and it parses the body of the request and completes the specified operation on the database. Originally, our Lambda function had the basic create, read, update, and delete operations, but as our app evolved, we made the Lambda function capable of handling more complex operations. For example, the code snippet you see on the right is from our Lambda function, and it handles the join event operation. This operation adds a specified user ID to a participants list of an event and a specified event ID to the upcoming event list of a user. 3 Dynamo DB tables were set up to store the data for our application: a users table, an upcoming events table, and an old events table. The Lambda function from the previous slide assumed an IAM role that allows it to access, read, write, update, and delete information from the table. Here is an example of data that is stored for the user in JSON format. To populate the user database, we used a Python module called Faker to generate fake names, emails, phone numbers, and a few sentences for the bio. Here's an example of event info stored in the database. And to populate the event database with interesting data, we used a Python module called Selenium to scrape the data for over 50 events from a website called volunteermatch.com. The name and email of the creator of the event, however, is made up. Our app uses 2 microservices that run every 6 hours behind the scenes to power certain aspects of the application. The code for these microservices were written in Node.js and containerized with Docker. Those images were then pushed to Amazon Web Services ECR, or Elastic Container Registry, and then scheduled to run every 6 hours on an AWS ECS cluster. The first microservice goes through each event in the upcoming events database and takes actions based on the event's date. If the event is past its date, then the entry is removed from the upcoming events table and placed in the old event table. If, however, the event is 1 week in advance, a 1-week reminder email is sent to each participant in the event. If the event is less than 2 days away, then a reminder email is sent to each participant with a reminder and the event info. The second microservice goes through each user in the database and calculates what events should be suggested to each user. It does this by counting up the number of times each tag appears in the user's past events and uses this information to rank the upcoming events. The top 4 events from that ranking are then stored as the user's suggested events and are displayed to them in their profile. Here is a screenshot of the Elastic Container Service console. You can see that the cluster is active and that a task which holds the images of the 2 microservices is scheduled to run every 6 hours.
I'm going to talk about some of the third-party integrations that we used in our app, right? So the first one I'm going to talk about is Google Maps, right? So on the event card, right, the old home, description, introduction information, right, the amount of money raised, etc. Right, and there's also the location, and there's a map displaying where this location is, right? You can zoom in, zoom out, right, and see where the location is. So the way we did that is that in the event card, right, the code where we display everything we want to display, right? So we display the description, we display additional information, we display the location, and we also display a Google map right over here. So we did that by calling this Google map. We call this code right over here, and this code calls the code, right, geocode code that we wrote, which the geocode code basically calls a function called geocode using an API key, right? And it gets it right over here. It gets the address. It gets the latitude and longitude based off the address that the event is at, right? And then right over here, it splits instead the result is just the latitude and longitude together, and it splits the latitude. It splits into 2 different parts, right? Latitude and longitude, right? 2 different variables, one starting latitude, one starting longitude, right? We need to do that because Google Maps can't get a map based off the address. It can only get a map based off latitude and longitude, right? So we get latitude and longitude, right? We set how big we want the what's the width, what's the height of the map, right? And the center of the map is going to be centered around the latitude and the longitude, right? And then this is the loader we're going to use to load the map using the API key. Fine, and then this actually loads the Google map, right? So that actually loads the Google map when it's called in the event card, right? So that's how we did a Google map. Next thing I want to talk about is the weather integration, right? That we integrated a weather, so you can see the weather for the next few days, right? So when a user looks at the event, so you can see that, oh, this is the weather for the next today and in the next 4 days, right? And so a few days before the event, he can come on and see, oh, what's the weather expected to be on the day of the event. So the way we did that as well is, again, we call it an event card, right? Right over here, right? We call it. And then also weather, it needs the latitude and the longitude in order to, it needs the latitude and the longitude in order to display the right weather, and it can't display the weather based on the address. So we also call geocode over here to get the latitude and longitude. And then we, the stat code actually displays the weather when it's called an event card. Yeah. And then we have the PayPal integration, right? Right here, we have the PayPal integration, right? So you can see that we have the money raising goal is 1,000, destination is 10, the amount raised so far is 125, right? So let's say somebody wants to donate, he wants to donate the amount of his destination, he wants to donate $10. So he presses submit, and then presses, let's say, PayPal. So I already have an account, so I just didn't have to put in all my information now. So but if one didn't have an account, they can make an account, or they could just pay as a guest, which is just putting in credit card information and not make a PayPal account. And then I press pay now, right? So you see right here, the amount raised so far is 125. So now when you reload the page, right, now you'll see that the amount raised so far will be 135. Just to give it a second to load. Right, you see that it used to be 125, now it's 135, right? So the way we did that is, again, we call an event card. We call an event card. We call we call the code that calls the PayPal bot, right? So payment, right? That's the code that has it. So we call that right over here. Right, it says donate here for whatever the event name is and how much you'd like to donate. Then it calls, this code calls a form, right, which will allow you to submit whatever amount you want to donate, right? That was the submit button that you saw right there, right? It takes in a donation, right? Yeah, and then it passes in that donation into the into this code right over here, which will update the database, right? It updates the database for this event, right, and sets the amount raised so far to the donation state, meaning the how much was previously donated plus whatever is donated right now, right? And this code also displays the PayPal button, right, which allows you to click and donate. So that's the three integrations that I was going to discuss.
I'm going to quickly go over with you how to build and run the app. So full instructions are on our GitHub README, but here's just a quick overview. So here are some of the things you'll need before we get started. So now you're going to want to go to our GitHub, and you want to clone our GitHub repository. And then once it's cloned, we created some CloudFormation templates so you can easily start all the AWS services that we use with some simple commands. So we have a template for our Lambda function, and we have a template, this is for our Lambda function and the API gateway and our databases, and then we also have a template for all the microservices. So once you run those CloudFormation templates, now you're going to want to finish setting up the API. So you're going to want to go to follow the instructions to enable cores with your API, and then once you have an endpoint for your API, you have to input that endpoint in API functions. So right here where it says endpoint, you're going to want to put your endpoint there. And there's also 2 more files where you need to insert your endpoint that are listed in the README. So now once you do that, you're going to want to also complete setting up the microservices. So we supplied them here. You're going to want to create a Docker image for each of these directories. Instructions are again in the README, and you want to push them to ECR and then schedule them to run every 6 hours. So now once those are done, you're going to want to set up Amplify. So in the README are simple instructions, simple commands you can just run that will do this for you. But just to show you, you need to create authentication and file storage in the backend environments for Amplify. So you can have your user authentication and some storage. And then also, if you want, you can add your front end to here, so that to the front end environments of Amplify, so you can have like your website can be hosted somewhere. You don't have to do this if you don't want, because you can always just run it locally. So now what you want to do is you also want to get an Open Weather API key and a Google Maps API key. And you're going to enter those in this file, where you can put in your Weather API key and your Google Maps API key. Now that you have all that set up and you're ready to run it, if you want to run it locally, first type npm I in order to install all your dependencies. So now we're installing all the dependencies that our app depends on. And now, once we did that, we can do npm start to run our application.
All right, now we're going to move on to the main takeaways and lessons learned during our summer program. So first, of course, agile development, maybe the most important thing we learned this summer was how to work together as a team, with all of us splitting up to do tasks based on our strengths and discussing our ideas and progress every day. It really was the reason why we accomplished what we did. With GitHub, we use Code Commit, which is basically just GitHub and AWS, and it was very, very effective. We were able to work and experiment on our own local code and edit it, test it, change it, see what the results were, and then only then push it when we were sure that it was good. So that was very, very useful, GitHub. Obviously, we couldn't have done it without AWS. All the services like Gateway, Lambda, Dynamo DB, ECS, Cognito, SES, S3. I already spoke about Code Commit, but without those tools, we most definitely could not have built an application as strong as this one, and it would have been a lot more difficult. Of course, using React.js was a really, really good experience. Learning about web development and front end and back end was a fantastic experience. Finally, by adding features like Google Maps, Weather, PayPal, we learned a lot about using REST APIs, how to call them in code. And these features, they really pushed our application to the next level. There would not have been as good of an application without these features. And that resulted in us learning a lot about REST APIs. So that's it. Thank you so much for watching our video, and we really hope you enjoyed.